And now for the fundamental theorem of calculus part 2. So basically this is just a restatement of FTC part 1, but it's stated in a way that makes it easy for us to evaluate the integral. Okay? Because what we've got is that, so here's my integral, and what this says is that what I need to do is I need to find the antiderivative of little f, that's going to be big F, and then I just evaluate it at the endpoint. So it's pretty easy as long as we can find the antiderivative. Okay? Now, what we'll see is as we go through the rest of this class, sometimes it's not as easy to find the antiderivative as other times, and we've got all these different techniques to do it, so we'll be doing a lot of that. But in this first section, this first week, we're basically just using the basic antiderivatives that you should already know and you should already have memorized. And just in case you don't, or you've forgotten, or it's been a while, if you'll take a look at the sheet that I have up in this week's in this week's module, you will see there I have a nice little PDF file of the ones that are important. Okay. So, all right, let's see how do we know this is true, or what does this mean? Well, it's not that hard to show this from the fundamental theorem of calculus part 1, right? So the fundamental theorem of calculus part 1, we have the following. We have from a to x of f of x dx is equal to g of x, right? Where g prime of x is f of x. So this g is actually an antiderivative of little f, right? And this f is any other antiderivative of little f. Well, as we know, if two functions are antiderivatives, they just are the same thing, but they differ by a constant, okay? So let's write this down a little bit better. So g is an antiderivative of f. Big F is also an antiderivative of little f. So big F and little g are basically the same up here. Right? Now that we have that, let's look at that right-hand side. F of b minus big F of b minus big F of a. Well, I don't really know what big F is, but I know what I know what little g is. So let's just put that in there. We're just going to put little g of b minus little g of a. Okay? Well, the plus c's cancel out, and that's kind of the point, right? Because I got plus c and minus c. So this is just little g of b minus little g of a. Well, if we go to what g of x is, we can figure out g of b and g of a, right? Just plugging it into here, g of b is this. And g of a, I plug in b, I plug in a, I have the integral from a to a, but we had said that's an integral that's going nowhere, that's 0. So what this is just g of b, and what is g of b? It's this guy right here, and that's exactly what we were finding. So we just went from the left-hand side to the right-hand side. Okay? So that was pretty straightforward because we already had done the hard work of proving the fundamental theorem of calculus part 1. So all this is just putting it in a slightly different form. So let me put it up here, and then we'll do a couple examples. I can't quite get up there. Sometimes I have to crawl on my chair. So what I have is the integral from a to b of little f of x dx is equal to f of b minus f. Right? Okay. So, now I have this whole nice board that I can do some examples of. And basically, as I said earlier, we're just going to look at some simple guys. Okay? So, some simple guys are going to be something of the form of 3 to 5 of x to the 1, oh, okay, x to the 6, right? So you got to go back and look at your antiderivative chart or your integral chart that I gave you. Now, the antiderivative of x to the n, right, is going to be x to the n plus 1 over n plus 1. As long as it's not negative 1. If it's negative 1, you're out of luck, right? It's natural log. But that's a special case. Something like this, we just put it in here. We know that it's going to be x to the 7 over 7. And then the way you write that, of course, is the bar. You evaluate from 3 to 5. Okay, so I don't have any idea what this number is. We'll just leave it that way. Okay. Since I don't remember what the 7th power of those things are. So you could, of course, just put it in a calculator. Okay. Because it's a definite integral, right? This will always be a number. It might be a negative number, it might be a positive number, right? But it's always going to be a number. Your answer should be a number. If it is something, let's say, 1 to 10 and 5 would be x minus x squared. Okay. Something like this. This is two different ones. As we know, I can do these separate. First of all, this is a 5. I can pull the 5 out. And then, right? So I can write this out. Now, mind you, I probably will never do that again. I'll just go ahead and straight do it. But you can write them separate. You don't have to. Now, e to the x, of course, is its own derivative. E to the x is e to the x. So that just stays here. This, again, is a power, so it's going to be x cubed over 3. Evaluate from 1 to 10. Okay. So now I've got 5e to the 10 minus 1,000 over 3. And then I'm going to subtract. I'm out of space here again. You know what? We'll get 5e. 5e minus third, right? So now we can clean that up a little bit. I'm going to, sorry about that. I have to be a little bit better about these little boards, right? So 5 times e to the 10th minus e, what is this? Minus 999 over 3, so whatever. You can put in the number. it's fine for me if it's got e's or pi's or whatever, just leave it. I would prefer that you left it in this form rather than giving me a decimal. But if you want to put a decimal, put a decimal. Not wrong. Some people like that. In any case, I would say that for WebAssign, do be careful and make sure that you put whatever they want. Like they'll say like what they want, whether they want exact or a number with whatever. Okay. All right, let me try to do a little bit better job on this board. See, I could have just started a little bit over there, and we would have more space. I got to get used to using a little board. Little board's a little bit better board work. It's important. Let's do another one. Here's one. Nice one in the book here. Y squared minus, well, y cubed minus 2y squared. I don't know. No matter, minus y over y squared. Okay, so something like this, it's a little messy. You need to clean it up first, right? Do just a little bit of algebra to make it into a form that we like. And by that we like, I mean that looks like something on the chart that we can then use it, because then I have y minus 2 minus 1 over y, so pretty straightforward. Now, when I go ahead and evaluate these, I've got y squared over 2 minus 2y minus natural log of y, evaluated from 1 to 3. Do you remember that the antiderivative of your 1 over x, dx over x, is going to be the natural log of the absolute value? In this case, we're all positive, so everything's fine, and we just plug in the numbers. Okay. Very common forms of common mistakes with this. You see how I use the parentheses, minus, and the parentheses, because very common mistake, not put in the parentheses, and then you don't distribute the minus, and then you get the wrong number. Natural log of 1 is 0. Okay, so this is going to be 9 halves minus 6 minus natural over 3 minus 1 half plus 2. So 8 halves is 4. 4, 6 minus 6, 0. I got minus natural log of 3. Okay? Which is going to tell me, yeah, so it's negative. There's more of that underneath than above the axis. Okay? Right. Oh, one more. Okay. But don't forget. Basic algebra, right? Because this is in the bottom, I can break that up. If I have something instead, like I can't break that up. This isn't 1 over x squared plus 1, right? Because it's in the bottom. So, but this is actually an important form. It's inverse tan. You should, when you see this, you should be able to recognize immediately, oh, that's inverse tan. The derivative, inverse tan of x what the inverse tan of 3 is, the inverse tan of 1 is, pi over 4. So we're going to leave it like that. Anyhow, so do remember those forms. They're on the paper, but they're important. We see a lot of the inverse tan in this class.